The National Electrical Code dictates specific guidelines for the installation of control wiring used in air conditioning systems. A key provision addresses the separation of this wiring from other types of electrical conductors, particularly within enclosures like electrical metallic tubing or EMT conduit. The requirement to install air conditioning control wiring outside of EMT conduit emerged in the 1978 edition of the NEC. This means that any air conditioning system installed or significantly altered after this date would have been subject to this rule. When evaluating existing installations, it's crucial to understand the code version in effect at the time of installation or alteration. The general principle is that electrical work should comply with the codes that were current at the time the work was performed. Therefore, if an air conditioning system was replaced in 1992, the 1978 NEC or a later edition would have been applicable, necessitating the control wiring to be run separately from the power wiring. Now, to delve deeper into the reasons and implications of this code requirement, let's consider the function of control wiring in air conditioning systems. Control wiring typically carries low-voltage signals that govern the operation of various components such as the compressor, fan, and thermostat. These signals are essential for the system's proper functioning and responsiveness to user settings. In contrast, power wiring carries the high-voltage electricity that supplies the energy needed to run the air conditioning equipment. Mixing low-voltage control wiring with high-voltage power wiring in the same conduit can lead to several potential problems. Firstly, electromagnetic interference from the power wiring can disrupt the sensitive signals carried by the control wiring. This interference can cause erratic operation of the air conditioning system, leading to inconsistent temperatures, frequent cycling, or even complete system failure. Secondly, the close proximity of high and low voltage wiring can increase the risk of electrical faults. If the insulation on the power wiring deteriorates over time, it could create a short circuit that sends high voltage electricity into the control wiring. This could damage the control system components and potentially create a fire hazard. Thirdly, the presence of low-voltage wiring in a conduit with high-voltage wiring can complicate maintenance and repair work. Electricians working on the system may inadvertently come into contact with the high-voltage wiring while attempting to troubleshoot the control system, leading to electrical shock. The NEC requirement to separate air conditioning control wiring from power wiring is intended to mitigate these risks and ensure the safe and reliable operation of air conditioning systems. By running the control wiring outside of EMT conduit containing power wiring, the potential for interference, electrical faults, and safety hazards is significantly reduced. Now let's explore the specific code sections that address this requirement in more detail. While the exact section numbers may vary depending on the edition of the NEC, the general principles remain consistent. The NEC typically addresses the separation of low-voltage and high-voltage wiring in articles related to wiring methods and conductor installation. These articles specify the types of wiring methods that are permitted for different applications and the conditions under which different types of wiring can be installed together. For air conditioning control wiring, the NEC typically requires the use of listed and labeled low-voltage wiring that is suitable for the environment in which it is installed. This wiring must be run in a manner that protects it from physical damage and prevents it from coming into contact with other conductors that could create a hazard. In some cases, the NEC may permit the use of a barrier or partition within the EMT conduit to separate the high and low voltage wiring. However, this is generally not recommended, as it can be difficult to ensure that the barrier is properly installed and maintained. The preferred method is to run the control wiring in a separate conduit or wiring raceway. When installing air conditioning control wiring, it is essential to follow the manufacturer's instructions and all applicable codes and standards. This includes using the correct size and type of wiring, properly terminating the conductors, and ensuring that the wiring is securely supported and protected. It is also important to label the control wiring clearly to identify its function and voltage level. This will help prevent confusion and ensure that future maintenance and repair work is performed safely. Now, let's consider some practical examples of how this code requirement is applied in real-world situations. Imagine a scenario where an older home has an air conditioning system that was installed before the 1978 NEC came into effect. The control wiring for this system is run in the same EMT conduit as the power wiring. In this case, the installation may have been compliant with the codes that were in effect at the time it was installed. However, if the air conditioning system is replaced or significantly altered, the installation would need to be brought up to current code. This would require the control wiring to be rerouted outside of the EMT conduit containing the power wiring. Another scenario involves a commercial building where a new air conditioning system is being installed. The electrical contractor is running the power wiring and control wiring for the system. In this case, the contractor must ensure that the control wiring is run in a separate conduit or wiring raceway from the power wiring. The contractor must also use the correct type of wiring and properly terminate the conductors. If the installation is not performed in accordance with the NEC, it could result in code violations, fines, and potential safety hazards. It is also important to note that the NEC is not the only standard that may apply to air conditioning control wiring. Other standards, such as those published by Underwriters Laboratories, ALL, and the National Fire Protection Association, NFPA, may also contain requirements that are relevant to the installation and safety of air conditioning systems. These standards may address issues such as the flammability of wiring materials, the grounding of equipment, and the protection of electrical circuits. Therefore, it is essential to be familiar with all applicable codes and standards before installing or working on air conditioning systems. In summary, the NEC requires air conditioning control wiring to be installed outside of EMT conduit containing power wiring. This requirement is intended to prevent interference, electrical faults, and safety hazards. The code requirement came into effect in the 1978 NEC, and it applies to all air conditioning systems installed or significantly altered after that date. When installing air conditioning control wiring, it is essential to follow the manufacturer's instructions and all applicable codes and standards. The potential consequences of failing to comply with these requirements can be significant, ranging from equipment malfunction and property damage to personal injury and even death. Therefore, it is essential for electricians, contractors, and homeowners to be aware of these requirements and to take the necessary steps to ensure that air conditioning systems are installed and maintained safely and in accordance with the NEC. Further, it's important to recognize that the NEC is a living document that is updated on a regular basis to reflect changes in technology and best practices. Electricians and contractors should stay up to date on the latest code requirements to ensure that their work is compliant and safe. This can be achieved through continuing education courses, professional organizations, and subscriptions to industry publications. In addition to the separation of control wiring from power wiring, the NEC also addresses other aspects of air conditioning system installations, such as the proper grounding of equipment, the sizing of conductors and overcurrent protection devices, and the installation of disconnecting means. These requirements are all intended to ensure the safe and reliable operation of air conditioning systems. When evaluating an existing air conditioning installation, it is important to consider all of these requirements and to determine whether the installation is compliant with the codes that were in effect at the time it was installed. If the installation is not compliant, it may be necessary to make changes to bring it up to current code. This could involve rerouting wiring, replacing equipment, or adding additional safety features. It is also important to note that local codes and regulations may impose additional requirements beyond those specified in the NEC. These local codes may address issues such as the permitting of electrical work, the inspection of installations, and the licensing of electricians. Therefore, it is essential to be familiar with all applicable codes and regulations before performing any electrical work. In conclusion, understanding and adhering to the NEC requirements for air conditioning control wiring is crucial for ensuring the safety and reliability of these systems. The separation of control wiring from power wiring, proper grounding, appropriate conductor sizing, and compliance with local codes are all essential elements of a safe and compliant installation. By taking the time to understand and follow these requirements, electricians, contractors, and homeowners can help to prevent accidents, protect property, and ensure that air conditioning systems operate safely and efficiently. Remember to consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical contractor before performing any electrical work. In addition to the specific requirements for air condition control wiring, the NEC also contains general requirements for all types of electrical wiring. These requirements address issues such as the types of wiring methods that are permitted, the installation of conductors in raceways, the grounding of equipment, and the protection of electrical circuits. It is important to be familiar with these general requirements, as they apply to all electrical installations, including air conditioning systems. One important aspect of electrical wiring is the proper selection and sizing of conductors. The NEC specifies the ampacity, or current carrying capacity, of different types of conductors based on their size, material, and insulation. It is essential to select conductors that are large enough to carry the expected load without overheating. The NEC also specifies the types of overcurrent protection devices, such as circuit breakers and fuses, that are required to protect electrical circuits from overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of electricity if the current exceeds a safe level. It is important to select overcurrent protection devices that are properly sized for the conductors and equipment that they are protecting. Another important aspect of electrical wiring is the proper grounding of equipment. Grounding is the process of connecting electrical equipment to the earth, which provides a low resistance path for fault current to flow back to the source. Grounding helps to prevent electrical shock and reduces the risk of fire. The NEC specifies the types of grounding electrodes that are permitted and the methods for connecting equipment to the grounding system. In addition to the NEC, other standards and regulations may also apply to electrical installations. These standards may address issues such as the energy efficiency of equipment, the accessibility of electrical panels, and the protection of wiring from physical damage. It is important to be familiar with all applicable codes and regulations before performing any electrical work. When evaluating an existing electrical installation, it is important to consider all of these requirements and to determine whether the installation is compliant with the codes that were in effect at the time it was installed. If the installation is not compliant, it may be necessary to make changes to bring it up to current code. This could involve rerouting wiring, replacing equipment, or adding additional safety features. It is also important to note that electrical work can be dangerous, and it should only be performed by qualified and experienced individuals. If you are not comfortable performing electrical work yourself, it is best to hire a licensed electrician. A licensed electrician has the knowledge and skills to perform electrical work safely and in accordance with the applicable codes and regulations. In conclusion, understanding and adhering to the NEC requirements for electrical wiring is crucial for ensuring the safety and reliability of electrical systems. Proper conductor sizing, overcurrent protection, grounding, and compliance with local codes are all essential elements of a safe and compliant installation. By taking the time to understand and follow these requirements, electricians, contractors, and homeowners can help to prevent accidents, protect property, and ensure that electrical systems operate safely and efficiently. Always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical contractor before performing any electrical work.